Okay, so we got around like 14 to 15 members here. So let's start the session today. So wait guys, I'm presenting my screen. So anybody please confirm, is the screen visible to you?
Yes.
Okay, so we'll start with TinkerCAD. Okay, now in the previous okay, nice. You can, if you don't want to turn on your mic, you can write in the chat box also. So in the previous SOAR class we talked about TinkerCAD and just basic introduction about microcontroller. So what is a microcontroller, and this I have also shown you like few equipments like that. Okay, people are joining here, nice. Let's go to TinkerCAD only. So if you don't have an account on TinkerCAD, it's very easy. You can sign in with Google, and within few seconds your TinkerCAD account will be activated. So this is TinkerCAD. I have signed in with my Google account. You can do also same. You can sign in Google account. One thing I want to do here, like it will be better you just do along with me. I'll going to make one very simple project here, like blink LED project. You can do the same also. So I'm giving you 2 minutes, like 1 or 2 minutes. You create a TinkerCAD account. If you are on your laptop, it will be very easy for you. Just go to TinkerCAD and sign in with Google. Okay, you can create an account, or if you're facing any problem, let me create another account from my side. You also do along with me. Okay, you go to TinkerCAD and you go to join now or sign in as per your wish. Then you can sign in with Google here, like you can sign in with Google. You choose an account. Yeah, okay. Yeah, then your account has been created. You can see your TinkerCAD account is created. It's my another Google account with the same name. So the TinkerCAD account is created. You can start making your designs here. Like if you can do 3D designs here, you can do circuit design here, you can do code block design here, and then lessons here also. I think this section is empty for now. So our main focus is with this part, circuit. We'll make various prototype of Arduino with using this TinkerCAD software. So I'm not using this account. So I hope you have created your TinkerCAD account. Like any questions here? Okay. Okay, nice. So let's go to TinkerCAD. Now to make on circuit, like you go to circuit section here, this circuit section, and if you have already used TinkerCAD, then you will see your past TinkerCAD models here, and if you are new to TinkerCAD, you will find that this section is empty here. So you go to create new circuit, you click on create new circuit and just wait for few minutes. And you just give it few seconds to load. Okay, it will take like five to 10 seconds to load. You will give it 5 to 10 seconds to load it perfectly. Okay, now this is the TinkerCAD dashboard here. There are many buttons here, like this button is for rotate, this button is for delete, this for back, this undo, redo, and this for you can hide this one, you can toggle the visibility of an item, and you can choose colors, you can choose lines here, and many more. In the right side, they've got the code part. There's the simulation. You can simulate what you have created here, and there is the option to share this project to your nearby friends. And in this section you got all the components here. Like first they will show you the basic components like a resistor, LED, push buttons, potentiometer. These are the basic components, capacitor, this is a battery. So this is the basic components. Now our main goal here is Arduino. So let's take on Arduino. Just type in the search box Arduino. You get, once you like Arduino, you get Arduino here. So click on here. Our focus will be on Arduino Uno R3. Just click on here and just drag and drop it here. Okay, just release it and drop it here. Now you can zoom out this version. That is just, you can, if you're using a mouse now, you just rotate your wheel in the mouse, it will get zoom out. Okay, so let's place the Arduino here. Now the first project we are going to do is using this Arduino we are going to control an LED as per our wish. So we will do somewhat like that. We'll take one LED, and with that LED we'll going to control this LED. We'll control the blink of that LED as per our wish. So we need an LED here. So let's take on LED and we'll place it here for now. And to make the connection, let's take a breadboard from here. Okay, so breadboard. So for this project we will create a simple small breadboard. Just we'll take a small breadboard here and put it here. Just make it a little more clear here. Yeah, okay. So these are the components that we are going to require for this project. Till now, if you have any questions, like if you haven't understood any part, you can ask. Like if you have any questions, you can ask, or if you understood, you can type yes, I have understood here.
Bhaiya,
Yes.
can I do it along with the online meeting?
Online meeting means this.
Means can I do the things that we are doing in TinkerCAD? Means I am also trying to do actually
Okay.
by remaining in the meeting.
Okay. Okay. You can do now. I told now you can do along with me. It's no problem. Till now, how much you have completed?
Means I have completed the basic module.
Basic module means.
Means that you have told
Okay. Okay.
to
You
learn
you
the.
have signed in now.
Yes, yes.
Okay. Then.
Then I have completed that basic training to how to use the TinkerCAD and
Hmm.
all that components.
Then.
Then I am learning with you
Okay.
now.
Okay. 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 Till now, are you with me along with this part? You got all these parts in your dashboard here.
Yes, yes, yes,
Okay.
sir.
Okay. Don't call me sir. Okay. Don't call me sir. Anyone, any other doubt you can ask? Okay, so I think everyone got up to this part. Okay, so our project is to control this LED. Okay, we'll control the blinking of that LED. So let's put that LED here. That we'll put that. Okay, we'll select that and put that LED here. Okay, then we'll connect the LED, the positive terminal of this LED with this pin number 13. Now 13, we will use that pin number 13, that this pin as a high voltage, that is we will use that for a positive terminal. So click on pin number 13 and drag and drop. You can drag, these are the wires. Okay, you are drawing wires from here. Just connect these wires here. So this wire has been connected. So this the positive terminal of the LED, you know that, you know how the basic internal structure of a breadboard, you know that these lines are parallelly connected with each other. So the positive terminal here is connected with pin number 13. Positive terminal of the LED here is connected with the pin number 13 of Arduino. Then we'll connect the negative terminal of the LED with the ground. Here you can see, here it is written GND. GND means ground. So we'll connect that with the negative terminal. So let's connect that. Click on the ground and drag and drop. We'll connect that with the ground. Okay, now you can see our basic connection is ready. Now the connection is ready. Now the main only thing with remaining here is the coding part. Now we will use coding here to make the circuit work, and we will control this LED as per our wish. Now the basic diagram is ready, the schematic diagram is ready. Everyone is up to here. Any doubt? Any doubt? Or you can type yes, you have understood, you can type yes. No doubt. Okay. Okay. So now we are going to do the coding part. Okay, you go here, it's code here, this is written now code. So you click on code. Now there are many options, there are many ways you can code. The first one is block. If you have used the software called Scratch, then you know how to use this block diagram. So this block diagram is not used for us. It is for, means if you are very, means very brief introduction, if you are totally beginner now, then you will use this block diagram for coding. Okay, but we are not beginners, we are not too much beginners, we know somewhat coding from our college. Like you are in first semester, you know, like few of you are in group A or group A or group 2, and then you know somewhat a C programming. So we'll use the coding here. Just click on block here and select text from here. Then it will ask you, are you sure? Then we will click on continue. Then we go. We got the coding section here. Now this coding section with Arduino, now it is really simple. It is similar to C++. If you are familiar with C++, now you will understand it quite easily. And if you don't know C++, then don't worry. I will explain each part, each section of this code, how this code is working. Okay. Now this is the boilerplate code. We don't need this one, so I am just removing this one. You can do along with me, okay, or else you will face in problem. Now for the code, we will bring that code from my machine. I have already written that code in my editor here. So this is the sample code here. Now this is a beginner friendly program. What the program does, it controls the rate of LED blinking as per our choice. As per our choice, we will control the rate of the LED blinking. Now there are two functions here, like these are the functions. Like the return type of the function is void. This function will not return anything. And this another function, void loop. This is the first function, that is void setup. In this function we set the, you can understand the behavior of this function by its name, void setup. Just you ignore what is void here, just you focus on setup. You know the setup means we are setting something up. So with the name you can understand that in this function we are setting something. Okay, so what we are setting, we are setting the pin mode. What we are setting, the pin we are selecting, and we are setting the mode here. So we are setting selecting the pin mode here. So these are the pins we are working with now. So we are setting the pin mode. So we are working with pin number 13 here. So we are setting pin number 13 as our output. Since we are working with pin number 13, we are setting pin mode 13 as our output. Now we are using only one pin here, that is pin number 13, and another is for ground. A ground pin, we don't need to write much code about the ground pin. It will automatically our program will automatically write that for us. The main thing, we have to consider all the pins from 0 to 13. So we are specifying that the pin number 13 as our output. Then comes our next function. Next function is void loop. Now void loop, you can say by the name loop. Loop means it will run continuously. So this function, what you have written inside this function, will run repeatedly. Okay, everything written within this function will run repeatedly from top to bottom. Okay, you have to keep in mind that everything written here will run from top to bottom. Means that the first line number 20 will execute, then 21, then 22, then 23, then will again go top, then again it will run 20, 21, 22 and 23. It will run repeatedly and it will never stop. Okay, until the Arduino is powered, that is until it is connected to the source, it will run repeatedly. So what our intention is to control the LED, okay, the rate of blinking. So first we have to turn on the LED now. So we will using digital write. Now what is digital write, you may ask, what is digital write? You can see here, like here is Arduino. These are you can see these is digital pins. All these are digital pins. Here it is written in Arduino board that digital pins, and these are analog pins. Now since we are dealing with digital pins, we are using digital write, means we are making an output now. So we are making an output, we are providing electricity here, we are providing a high voltage here. So that means we are writing something. So we write digital write. What we write? In digital write, we specify the pin number, that is pin number, and set the voltage to high. Means we are asking Arduino that, hey, just go to pin number 13 and set the voltage to high. Then we will say here delay. Here delay means there is a delay in time. Here delay means the time taken to go to this section. Like it will delay it is in millisecond. Okay, 500 milliseconds means it will be around half seconds. So it will be delayed by half second. Now it will delay half seconds to go to this line number 22. Then we will again, once we have turned on here the LED here. Now our task is to turn it off so that we got the blinking effect. So again we are writing digital write pin number 13, and we to turn it off we set the voltage to low. So this is the simple code, and we again delay f500 milliseconds. Okay, you can do the delay as per your wish. You can delay like 5000 milliseconds, like it will be around 5 seconds delay, but we don't need that much delay. We are dealing with 500 milliseconds, like half a second delay. So get a half a second delay here. Okay, so this is the code here. This is I think it is very simple. If you have any doubt regarding the coding part, that if you haven't understood any single part, you can ask, or if you have any doubt regarding the coding part, you can ask here.
Bhaiya, can you again explain that output one pin mode 13 comma output?
Okay, pin. You can see this is the pin. This is now pin mode 13 equals to output. So
Yes, Bhaiya.
this function is void setup. You can get the name, like setup means you can setting something up. Okay. So in this function you set all the parameters. So in these parameters you are setting the pin, you are selecting the pin, and what you are doing, the pin mode. We are setting the mode of the pin. Means we are setting the state of the pin. We are setting what the pin number is 13. We are setting the pin mode 13 as output. Okay, we are setting, since we are blinking this led now, we have to give here a high voltage. So we have to tell Arduino that this is the mode of the pin is output. We are placing a high voltage output from this pin. First we have to tell Arduino that we are using that pin number 13 as output. So have you understood that?
Yes, Bhaiya, thank you.
Okay, any other query?
भैया
Yes.
सॉरी भैया ये मतलब ये जो वॉइड सेटअप पार्ट है भैया, इसमें जो कंपोनेंट्स होता है उसको डिफाइन करते हैं, और जो लूप वाला पार्ट होता है उसमें मतलब ऐसे उसका फंक्शनैलिटी डिफाइन करते हैं मतलब
तुम इसे समझ सकते हो कि एकदम जो अगर तुमने सी प्लस प्लस यूज़ किया है, तो सी प्लस में एक मेन फंक्शन होता है जो सबका मेन होता है, ठीक है। तो तुम इसे इस तरह से ले सकते हो कि ये जो वॉइड लूप है ना, ये सबका मेन फंक्शन है। ओके, ये बार बार चलता रहेगा। ओके, और जो वॉइड सेटअप है उसमें तुम क्या करोगे, सबको डिफाइन करोगे कि ये वाला इस तरीके से काम करेगा, 13 नंबर इस तरह से काम करेगा, 13 नंबर में आउटपुट होगा, 14 नंबर पे इनपुट होगा। तो तुम्हारी मर्जी। ओके, समझ में
ओके
आया?
भैया, ओके समझ गया।
ओके,
थैंक यू।
एनी अदर क्वेरी? I think everyone has got. If you got up to this part, just give a thumbs up, or you can say yes, I got up to this part. Just type here, got up to this part. Just make sure everybody is here with me. Okay, got it. Okay, thumbs up. Got it. Okay, Krishna, Rimi. Okay, got it. Okay. Now the coding part is, I think the coding part is clear. So we'll put that code here. Okay, we'll put that code in this Arduino here. Select the Arduino, go to code, and you will paste this code here from your local machine. You will paste this code from here. Okay, I'm just copying it for it. Setup, copy. I'll paste it here. Yeah, it's okay. It will automatically get saved. I'll just zoom it out. Okay, once I start the simulation now, the circuit will get activated and it will run. So what we have written here in the coding part, that the LED should blink with a delay of half a second. Okay, so let's start the simulation here and see what happens. You just keep an eye on this LED. Okay, I'm starting the simulation. Okay, the spelling mistake. Alright. Okay, yeah, the circuit got turned on. You can see the LED is blinking as per we have, this is written here. It is blinking with a delay of half a second. Okay, you can see the LED is blinking. Now you can bring this LED as per your choice. We have already mentioned, we are controlling the rate of LED blinking. So till now our LED is blinking really fast. The rate is really fast. So let's delay the rate. Okay, let's delay the rate, like someone will stop the simulation for now. Let's delay the rate, like, okay, you guys tell me what will be the delay rate. Like, I'll give the delay rate as per your choice. Like, you tell me the delay in seconds. Okay,
1000.
1000 seconds.
No, no, sir. 1000 millisecond means 1 second.
Okay, 1 second. Okay, first, okay, we got minutes for 1.5 and 3. Okay, first we'll got 2000, then we'll come to 3 seconds. Okay, so 1000 millisecond means 1 second. Okay, so we'll get the delay. Okay, so let's start the simulation. Okay, you can see the LED is blinking. I think someone mic is on. Divjit,
Vipajit, Vipajit Das,
please
could you
turn off
please
your
turn
mic.
off your mic?
He is outside. Okay. Never mind. चलता है ये सब ऑनलाइन क्लास में चलता है. Okay. You can see the rate has somewhat decreased. First it was like half a millisecond, and the rate is around 1 second here. Okay, now we got another response here like 3 seconds. Let's do it 3 seconds. Like 3 seconds we got 3000 milliseconds. Okay, we got, now we should get a delay of 3 seconds. Okay, let's start the simulation here. Let's start the simulation. The LED is on. Let's go to, you can see the time here, like it will turn on 6. Yes, it turns on 6. Again it will turn off on 9, turn on 12, turn on, yeah, it turned on 12. Again it turn on 15. Yeah, then it will turn on 18. You can see it's working perfectly fine. Now one thing is really nice about here. If you can control an LED now, then you can control everything. You can control a fan, you can control a light as per your wish, as per your requirement. You can control anything. If you can control an LED now, and you can control anything. Okay, this, let this simulation run for now. If you have any queries, define delay time in both. Okay, no problem. Let's try this one. Okay, no problem. Let's try this one. Like, let's give it 1 second. Let's try. Okay, you can see 3 seconds. You can see what's happening here. First, this function is delayed. This line number 14 is delayed. I can zoom it. Okay, just wait a minute. Okay, see this line number 14. First, we have written here delay 3 seconds. Okay, so the what the program is doing, it delayed 3 seconds before coming to this line. Okay, then it will, then it takes a delay of 1 second, then it comes back here, then again it runs from here, run from the top. Okay, so if you write here delay 100 milliseconds, that means delay 1 second, that means it will delay 1 second before coming to the top. Okay, I hope it is clear now. Swami, like, is it clear to you? हेलो, इज इट
भैया
क्लियर?
मतलब भैया मतलब ऑफ होके ऑन होने का जो इंटरवल है वो 1 सेकंड है और ऑन से ऑफ होने का इंटरवल 3 सेकंड है, यही ना?
हाँ हाँ, यही.
ओके भैया.
You can do some, or you can do experiments here. You can do anything you want. Like, just, you can do many projects here. This is somewhat like prototyping. Once you get your desired result in the prototyping, now you can build the circuit in physical mode. So you can see we got our desired result. We are able to control this LED here in our prototyping. Now once you got success in prototyping, now you can make the real world physical project. So let me do the physical project here. I have this Arduino ready here for you. We'll upload the same code here. Okay, let me join from my phone. You'll not be able to see it. Okay, I'm joining from my phone till now. If any, okay, if you have any queries, you can ask. Yeah, I think I got it joined. Let me turn off one. Hmm. Okay, so you can see here, this is the
you can see here, this is
Arduino here.
Arduino here.
So
So
I
where
have
I have
already
already
created this
created the
circuit here. I
circuit
have
here. I have
connected this
connected this
LED
LED
here,
here,
this
this
LED
LED
to the
to the
positive terminal
positive
of the
terminal of
LED
the
to
LED
pin
to
number
pin number
13 here.
13 here.
You can
You
see
can
the
see
pin
the pin
number. I
number. I
think it will
think
be
it will
not
be not
visible to you
visible to you
because of the
because of the
lighting,
lighting,
but I have
but I have
connected it to
connected
pin
it
number
to pin number
13, the
13, the
positive
positive
terminal, and the
terminal, and the
negative
negative
terminal
terminal
to pin
to
number
pin number
to the
to
ground.
the
Okay,
ground. Okay,
the
the
positive terminal
positive terminal
is
is
connected to pin
connected to pin
number
number
13,
13,
and the
and the
negative
negative
terminal is
terminal is
connected to
connected to
ground here
ground here
in this
in this
Arduino.
Arduino.
So we
So
got
we
the
got the
success
success
in the
in the
prototyping.
prototyping.
So
So
we'll do
we'll do
something here.
something here.
We'll do
We'll do
the real
the
world
real one
physical
physical
project here.
project
So
here.
let me
So let me
connect this
connect
one
this one
to my
my
laptop.
laptop.
Yeah,
Yeah,
it's got
it's got
connected. You
connected.
can
You
see
can see
the
the
Arduino switch
Arduino
is
switch
on.
is on.
There is a
There
light
is a
here.
light here.
It tells
It
you
tells
if the
you if
Arduino
the
is on
Arduino
or
is on
not.
or not.
So
So
if I
if
have
I have
connected it
connected it
to my
to my
laptop,
laptop,
so the
so
Arduino
the
is
Arduino
on
is
here.
on here.
So let's
So let's
upload the
upload
code
the
here. You
code here. You
can
can
see my
see my
screen on the
screen on the
laptop. I am
laptop. I am
uploading the code
uploading the
here.
code
Okay.
here. Okay.
Then you
Then
see
you see
the LED
the
here.
LED here.
Okay. I'm
Okay, I'm
uploading the code
uploading the
here.
code here.
So
So
this is the
this is
code
the
here.
code here.
So I'm going
So
to
I'm going to
Arduino,
Arduino
upload.
upload.
You can see.
You can see
You can see
you
the
can see
LED
the
is
LED is
blinking.
blinking.
We got the
We got the
same
same
result in the
result in the
prototyping as
prototyping
well as
as
the
well as the
physical
physical
application here.
application here.
You can see
You can
the
see the
LED is
LED is
blinking with a
blinking with a
delay of
delay
half
of
a
half a
second.
second.
Let's do
Let's
something
do
here.
something here.
Let's
Let's
close this
close
one
this one
and
and
give it a
give it a
delay of
delay of
3
3
seconds,
seconds,
and this
and
one
this
give it
one
a
give it
delay
a
of
delay of
1 second.
1 second.
Okay, just
Okay,
save
just
it
save it
and go to
and go to
Arduino,
Arduino,
and I'll
and
again
I'll
upload
again
the same
upload the
code.
same code.
You can see
You
the
can see
LED
the
is
LED
on
is
for
on
3
for
seconds.
3
It
seconds.
will
It will
turn off
turn
for
off for
1 second,
1
then
second.
again
Then
it
again
turned
it
on for
turned on
3
for
seconds.
3 seconds.
You can
You
see
can see
the
the
same that we
same that
got,
we got,
the same
the
result
same
we
result
got
we
in the
got in the
prototyping. We got
prototyping.
the
We
same
got the same
result in the
result in the
physical
physical
model here.
model here.
So this is the
So this is the
beauty of
beauty of
using this
using this
TinkerCAD
TinkerCAD
software. If you
software. If
get
you
the
get
desired
the desired
result in
result in
TinkerCAD now,
TinkerCAD now,
if you
if
can
you
able
can
to
able
make
to
the
make the
same
same
the model
the
that
model that
you have done
you
in
have done in
TinkerCAD in the
TinkerCAD in
real
the real
project, like
project,
real
like
physical
physical
project, then it
project,
will
then it will
behave
behave
exactly the
exactly
same.
the same.
You can
You
see
can see
the
the
project here
project
is
here is
behaving
behaving
exactly the
exactly
same
the
what we
same
have
what we
done
have
in
done in
TinkerCAD.
TinkerCAD.
So I'm
So
just
I'm just
turning it
turning
off
it off
now.
now.
Okay, this
Okay, this
TinkerCAD.
TinkerCAD.
Now,
Now,
if you have
if you
any
have
queries,
any
you can
queries, you
ask.
can ask.
Bhaiya, uh, that simulation part, can you show that page? There is a doubt.
Yes, yes, you can ask. Please repeat again. The audio
Yeah,
gets
that
little.
simulation part, simulation
Okay,
on
okay,
that
wait, wait,
page, that
wait, wait.
TinkerCAD page.
Hmm.
It's where the connection that is given there.
Hmm.
Yeah, and that connection by the LED one, it is connected to that 13 number port or something that we have given in the
It is a pin.
Arduino.
It is a pin. You can see it is a general input output pin. It is a somewhat like a socket where you put your pin here.
Okay, one is ground and other is 30.
13.
Just a connection. And bhaiya in the LED where in the breadboard bhaiya. Oh, it's randomly given anywhere. It's not like that number given on the breadboard 13.
No, no. The breadboard number 13 has no relation with this Arduino here.
Okay, okay, okay. Okay, bhaiya, understood. And we have to connect it to the means all the points of that 2 points are serial in series connected in the breadboard. In one line, all of them are in series
You can
connection.
see. Wait, wait, wait. I am zooming it out. This all three lines now. All three lines. All five lines here.
Yeah, yeah,
All are connected with each other. Okay.
yeah. In a single line.
Yeah,
Oh,
yeah, yeah.
yes. Yeah, understood. We.
For making it more clear, let's go and see the internal structure of a breadboard. Okay, internal structure
Okay.
of breadboard. Yeah, you can see. Yeah, all these lines are connected. You can see now, all these lines are connected here.
Yes, yes.
Okay, so any more questions? Like if you have any more questions, you can ask. Like if you have any doubts regarding Arduino, anything, any software, TinkerCAD, anything you can ask.
Yeah, I didn't attend the previous. Means if you have taught something else in previous class, this was my
The
first.
previous was the first SOAR class. It was somewhat like a brief introduction about. It was just an introduction part. Like it was a like introduction about this what you call this multimeters and breadboards and small things. This you I guess you already know how what is a resistor, what is a capacitor, how to use a diode. You already know, no? So these are the things. A few basic things are discussed in the previous class.
Okay, Bhaiya.
Okay, anything more? If not anything more you want to ask, so I'm showing you another project. Okay, this is the simple project. Now you can make any project as per your wish. Let's go and make another project. Like I'll not close this one, I'll open another tab here. Yeah, this project you already know. This one, this project, it is an alarm system. You can see the code is here. Okay, so since you have already understood what is the use of setup function, what is the use of loop function, what is digital write, what is delay, then let me tell you how this is working. Okay, I will not explain each and every part. I will just go just a walkthrough of this project. Okay, so first let me show you how this is working. So this is an alarm system. The LED here, this red color LED will get turned on if an object come within the range of 100 centimeter from this ultrasonic sensor. This is an ultrasonic sensor. So let's start the simulation here. Yeah, just click on. You can see that the distance here is 183.4 centimeter. Okay, so you can adjust the distance of the object. Let's put it at around less than. You can see the LED gets turned on. The distance is less than 100 centimeters, so the LED gets turned on. So let's see how the working of this code. Yeah, first we are declaring some variables here. So that means so that we don't need to again write and each and every line, this pin number 16, like pin number 15. We don't need to write each and every one. We are declaring some variables. Now this you know that these variables will not change. The pin number 13 here, this trigger pin, you can see in this ultrasonic sensor there are many pins. VCC you know, GND you know. This is the trigger pin and this is the echo pin. The trigger pin will be used to make the ultrasonic sound and the echo pin will listen to that sound. Okay, you can simply say like the trigger pin will create the ultrasonic sound and the echo pin will listen to that ultrasonic sound. What this trigger pin generate, it will listen back that ultrasonic sound. Okay, so we got trigger pin, that's pin number 5, and echo pin, that's pin number 6. And we got two variables here, long distance and float distance. So no problem, you can the long duration and long distance. Then void setup, we set up the pin number this 5, there is trigger pin as our output and echo pin as our input. You can see here the trigger pin will be used to generate the ultrasonic sound. That means we are generating something from here. So we have set this trigger pin as our output. And since we are listening to the ultrasonic, that is what the ultrasonic is returning after hitting some objects. Since we are listening something, we are taking its input now. So we have declared the echo pin, that is echo pin here. We have connected it to pin number 6 here, you can see. We are declaring this echo pin as our input. Since we are listening to that, we will declare that as our input. So our echo pin will be input and our trigger pin will be our output. Then our pin number 13 will be again output. This is for the LED. You can see we already know this. This for the LED, we will set this as our output. Then void loop. Okay, first is we'll generate the ultrasonic sound. Okay, our task is to generate the ultrasonic sound and we'll listen to the same ultrasonic sound that is going to hit and come back after hitting an object that is maybe at a distance of 5 centimeter, maybe at a distance of 100 centimeter. Okay, it depends upon the object. So first we'll generate then ultrasonic sound. So we'll initialize this string this ultrasonic trigger pin. First we'll initialize. So first we'll initialize this as low. We are just initializing it. Then we'll delay a 2-second delay. Then we'll generate the ultrasonic. We'll generate a high ultrasonic sound. So we keep the input here as high. Then we delay a 10-second delay. Then we'll again write digital light. We'll turn it off. So what we have done here, we have created an impulse of ultrasonic sound. You can see first we got a low ultrasonic sound, then we created a high, then we again created low. That means you have created an impulse of the ultrasonic sound here. So till now, any doubt?
भैया वो इनपुट और आउटपुट वाला पार्ट एक्सप्लेन कर दीजिए ना, समझ नहीं आया।
ओके देखो ये वाला देखो, ट्रिगर पिन जो है ना, इसमें क्या है, हम इसमें जनरेट कर रहे हैं। देखो इसमें हम अल्ट्रासोनिक साउंड जनरेट कर रहे हैं यहाँ से। तो अगर हमको अल्ट्रासोनिक साउंड में डिस्टेंस सेंस करना है, तुमको पता है ना सोनार जो होता है ना, सोनार सुना है ना नाम?
यस भैया, यस भैया।
सोनार में क्या होता है, दो तरह के डिवाइस होते हैं, एक होता है ट्रांसमीटर और एक होता है रिसीवर। ट्रांसमीटर अल्ट्रासोनिक साउंड जनरेट करेगा और रिसीवर उसको रिसीव करेगा, जो अल्ट्रासोनिक साउंड किसी भी ऑब्जेक्ट को छू के वापस आएगा। ठीक है, तो जो रिसीवर होगा वो किस तरीके से काम करेगा, वो हमारा काम करेगा एक इनपुट की वे में। ठीक है, और जो ट्रांसमीटर होगा वो होगा एक आउटपुट। तो इसलिए हमने यहाँ पे डिफाइन किया है ट्रिगर पिन एज आवर आउटपुट and echo pin as our input. Okay, and this is the LED now, pin number 13. So it will be obviously it will be our output. So is it clear?
Yes भैया, thank you.
Okay, then we created an impulse. So if anyone have any doubt in the impulse, this impulse part, any doubt in this impulse part?
Why 10-second delay भैया?
It is up to your wish. You can delay a 20 millisecond delay also. It is up to your wish. I have given it as per my wish. You can give a 20 millisecond delay. You can this is the time where what is this? Thank you for using, sir. Okay, no problem. This is the time up to which the ultrasonic sound will persist. Okay.
भैया won't it changing the value won't affect the result?
No. It will affect. It will change the result, say like 0.1% or that one. This will not hamper much. Okay.
Okay भैया, thank you.
So this is the impulse we have created. Now the impulse we have created. Okay. Now we have to listen the impulse. That is, since we have created an ultrasonic sound now, so the ultrasonic sound will go and hit an object and will come back. So we have to listen that coming back ultrasonic again. So we are using the duration here. The duration will be time now. So we are listening that duration here. So there is a function that is predefined here. This is called pulsing. Pulsing, you might be confused what is pulsing. So simply you can say that this function is used to take the input. Okay, this function is used to take the input from the echo pin here. Okay, you can go to Arduino documentation and learn more about pulsing function. I am not explaining what is pulsing here. So you can simply say this pulsing function here is used to take the input from this echo pin. So to take the input, we first give the this current to this echo pin. So first we get the echo pin as high. So after placing the echo pin high, the echo pin will take the input, and then we have to sense the distance. Now this distance we have sensed it using 0.034 into duration by 2. Now this is the mathematical expression here. You can calculate this mathematical expression if I have studied more about sonar in your class 11 or 12. If you have studied more about sonar, you know how to calculate the distance using a sonar. Okay, now this is the distance and the duration we have calculated here. Okay, now our task is to sense if the distance is less than 10 centimeter or 100 centimeter as per our wish. Now this distance now it is in centimeter form. Okay, not in meter, it is in centimeter form. Okay, if you want to convert it into meter now, first you have to convert that centimeter to meter, then you have to do the calculation. But we don't need that much width of distance here. We'll do it in centimeter distance. Okay, so first I have written an if else condition here. If the distance is less than 10 centimeter, here you can see if distance is less than 10 centimeter, we'll turn on the LED. We'll turn on that LED. Okay, we'll turn on that LED, we'll get a delay of 200 milliseconds, then we'll again turn off that LED. This will give us a blinking effect. Just make it more clear here. Yeah. Else, if the distance is greater than 10 centimeter, then we will not turn on the LED. So we'll give here a digital write pin number 13 as will not turn on the LED. Then after this function, we will get a delay of 300 milliseconds. Okay, so this is the way this function is working. Now I think it's clear to you. If you have any doubt, you can ask. If you have any doubt, you can ask.
सर भैया भैया मतलब हर एक कंपोनेंट का जो स्पेसिफिक एक्शंस होता है, मतलब जैसे इसमें पल्स जनरेटिंग का था और मतलब किसी और में होगा, तो वो सारा मॉड्यूल खाली जानना है ना भैया, मतलब इसका मतलब ट्रिगर करने का।
तुमको बस ये जानना है कि ये कैसे काम कर रहा है, कैसे मतलब कब तुमको पल्स जनरेट करना होगा, कब तुमको पल्स इनपुट लेना होगा, ये सब तुम सीख सकते हो। आर्डिनो के जो डॉक्यूमेंटेशन है ना, वहाँ पे जाके सीख सकते हो। भैया, कैन यू शो द प्रीवियस प्रोजेक्ट कोड फॉर अ सेकेंड? ओके, previous project, there's blink LED na. Okay, this one.
Okay, भैया।
Bhaiya, can you explain that pulse in part again function?
Pulse in part. I was thinking you people will ask about this pulse in part. If I go into now explaining this pulse in part, you will be like, what is happening? I don't know this one. You can go with Arduino documentation here. I'll not explain. It will take huge time. Okay, to explain this pulse in part. We can explain this on in our later or upcoming classes. For now, you can just say that this pulsing function, what it does, you can say like you consider it like a function. Okay, just be simple, you consider it like a function. It will take the input from the echo pin. Okay.
Okay, bhaiya.
Bhaiya, can you show the
Basically
previous project? Yeah, Aryan, you can ask.
बेसिकली वो सीन टाइप का काम कर रहे हैं, जैसे वहाँ से तो सबने सीन काम करता है, वैसे ही है ये।
Okay. Bhaiya, can you show the previous project? You can see this one. Yeah. If you wish, you can take a screenshot here also. Or if you don't want to take a screenshot, you can see this the same code. It is present on our GitHub. You can see on our GitHub account. I'll post the GitHub link in the WhatsApp group. Okay, after the session I will post the link in the WhatsApp. Okay, so that's all from my side. This is that how to use the TinkerCAD, how to use this project. Now next Harsha will continue. Harsha will talk about microcontroller. So Harsha, you can continue from here.
Thank you भैया।
Yeah, okay.
Hello, good evening, everyone. Now I will speak about microcontroller. Actually, you have seen the programming part now. Now you have to see the electronic part of microcontroller so that you can program it well. Actually, you can see my screen. No?
Yes sir.
Yes, bhaiya.
Yes. Here you can see the microcontroller. No? This microcontroller, actually the main part is this thing. This is a Atmega 328P microcontroller. Actually, it will why it is called a microcontroller, because it will be having an processor, memory, and some peripherals so that it can communicate with other devices. Actually, it for a I mean, you are having computer now. It will be having an processor and memory. Similarly, this is an microcontroller is an you can assume it like a small system having a processor which can do mathematical operations and everything, and it is also having some memory. It is having 32 KB flash memory where you can write your program. And while running, this will be always changeable. Every instruction you will write in the Arduino IDE will store here. Then when the program runs, it requires some RAM, right? Even while we are running some applications, it will be requiring RAM. Similarly, it is also having an RAM of size 2 KB. And this is EEPROM. It is a long-term storage device. Actually, this SRAM, you have came across this things, no? RAM, whenever it isn't powered by electric source, then only it will have the memory in it. Whenever we turn off the power, the data gets erased. But if EEPROM, the data will be stored for uh, long-term purposes. These are a few things about. And in programming, you have also seen that you are writing some delay of 500 milliseconds like that, no? uh, for that thing, in this microcontroller, it will be having an oscillator. It is an crystal oscillator. You can check about these things in detail later. Just I'm saying about things you have to explore to know more about this thing. And you can see the oscillator is located here. And now I will say about these pins. Uh, Actually, in this Atmega 328P mounted on this board, now these pins are connected here. I mean, actually, these are extensions of these pins. And in this, these are called GPIO pins, general purpose input output. Uh, every time you will not give output now. If when we are turning an LED, we will be requiring this output part. I mean, we are giving a certain voltage to the LED so that LED is glowing. And sometimes we will be also requiring this input. uh, you saw the input case in sonar project, no? There where you will be taking duration. Actually, the pulse in will keep the echo pin to high. Whenever trigger signal comes to the sensor, it goes low. Whenever it goes low, this this duration from high to low, the time that pin will be kept at high will be recorded. For that thing, again we will be requiring this oscillator, that it will be writing the duration of signal going to the distance and coming. I mean, this two-way distance it being recorded. This time is being recorded, and we know that distance is equal to v. uh, this will be the sound of signal there, and this time will be half the total time, because we will only require the distance, one distance now. If we take vt directly, we will get the two-way distance. Then and someone asked about built-in LED. You can see here, and you can I will show you this reference page. I mean, actually, you can go through some YouTube tutorials to learn about these things. And after getting some basic idea, you can always refer this language reference page, where you can get these pins. Actually, how, I mean, what they do. This is a digital read. This will read whether given input. I mean, digital read. In the name itself, it is reading an digital value, with either the given input is high or low. It will it give. I mean, it will, there will be description and syntax to write in Arduino IDE, and parameters to pass in it. Actually, you will be passing only whenever you write a digital write, you will be writing. I'll show you. You will be writing you will be passing two parameters. No, one will be the pin, where in earlier case 13, and the value high or low, I mean whether you want to turn it on or off. Similarly, in the digital read pin, we will be reading the pin. No, I mean we are not giving any instruction, just we are reading that pin, either it is at 5 volt or 0 volt. Actually, every pin on this board, I mean, this whole board will work at 5 volts. And I'll speak about this pins. You'll mean, and in these things, there will be an PWM pins. In digital pins itself, there will be an PWM pins. What these pins do is, when we are using motor drives, we can control the speed of the motor by giving an pulse signal with duration, so that resultant voltage will be 3 volt. I mean, you can explore this concept PWM. In digital pins itself, there are PWM pins. You can see them. I'll zoom it a little bit. There's a uh, wherever you find this mark, these pins are supported. These pins will support this PWM, pulse width modulation. And again, these are about digital pins. Either you can give 5 volt or 0 volt as output, and input you can take 0 volt or 5 volt as input. Whenever you are having an high voltage here, you have to cut it down to 5 volt, so that this board will be safe, and it will generate 5 volt, and current from this pins will be very low, around 20 to 20 milliampere. uh, it cannot provide high currents. And uh, and I will say significance of this ground pin also. Actually, whenever you are making any circuits, it is mandatory that ground pin of this circuit, either sensor and everything, must be connected to this ground pin, and then only this circuit will be closed. If you think that you will be connecting an battery, I mean, you will be powering this source differently, but controlling it with assume and motor drive. If you connect motor drive with motor, this is a motor drive and this is a motor, and it is connected to this connect. 1 second. I'll draw. This is Arduino board, and this is an motor drive and motor. Arduino motor drive, and this is motor. You will be connecting motor drive and motor and you will be powering this motor drive with a battery.
So yeah, what is a motor drive?
It is a module. Actually, no, this, I'll say about it. You are having 5 volt and 20 milliampere. It is a very less watt to run a motor. I mean, it will it will cause this Arduino to burn. If you try it in TinkerCAD, then it will work. But in practice, what happens is either your microcontroller will burn or the motor won't run. To achieve that thing, we will be using a motor drive. On this motor drive, we will be having an IC and an switch and everything. You can explore that motor drive in detail, but I will say what it does. Actually, you understood not this thing, because it will be having I mean, very less power produced by this Arduino. It cannot turn on motor. So we will be requiring an external circuit to control. This motor drive can control the speed and clockwise or anti-clockwise direction of motor. Anti-clockwise direction of motor and speed. Uh, what it does is it will be using this. I'll bring one motor drive circuit. Now you can see now this is a motor drive. It will be having a circuit to control a motor drive. These two pins are called output pins. This motor drive can control two motors. Motor 1, motor 2. It will be having an H bridge. Actually, it is a circuit which will be switching, which will do the switching operation. And you can explore this circuit also in H bridge. If you have notes, you can write this thing. Actually, H bridge will be used for controlling clockwise or anti-clockwise of this motor. And other thing, I mean, I'm saying now here we will be having this pins. Actually, for controlling one motor, we will be requiring 3 pins from Arduino. One pin for controlling speed. It will be an analog output, and remaining 2 pins for controlling clockwise or anti-clockwise. I mean, direction of rotation, to control direction of rotation. 2, 3 pins for. Here you will connect a motor, and here you will give power source. Battery, you will be connecting an battery here, and you will get an 5-volt output in this. You can use this for powering your microcontroller, but it is not recommended to do that. And you have connected this thing now, and now you have connected these 3 pins to the Arduino. If you give some analog right, this pin, let us say analog right, we are having we need to give this PWM pin, D10. Let's give D10 as a 10 comma some 250, and we have to give these 2 pins as if we want either direction. I'm giving as high. You have to give high, low. I mean, these two must be different. You can check whether giving it high and low makes it clockwise or anti-clockwise, but these two must be different. If they both are same, this motor won't rotate. Now we have made all connections. Now, do you think this will work? Anyone? We have given every connection, and we have provided everything it will be requiring. Hello? Hello?
Yes.
do you think this motor will turn? I mean, will be turned on?
Have we provided the power?
We have provided the power here, battery.
It should work.
It should work if it's getting the correct command from the main Arduino.
It won't work because actually we haven't connected this ground to Arduino. Actually, we have to connect. We have connected this, make powered this source by connecting negative and positive terminals here, but we haven't connected this to. I mean, this is an open circuit. If we won't connect this to Arduino, the circuit in the Arduino side will be an open circuit, right? It is giving high with respect to what? It is giving low with respect to what? I mean, if 0 volt and it's giving 5 volt, and it is giving 250 by some 1023 into some 250 by 1023 into 5 volt. It is giving everything, but with respect to what? I mean, the potential with respect to ground only, na? It will be at 5 into 250. I mean, this voltage or 5 volt or 0 volt.
Yes,
We haven't provided
समझ
this ground. So whenever we provide this ground, this module, I mean, this motor driver will work. Do you understand the importance of ground? So it is a common mistake. I mean, even I did. I have read about this motor drive, and I have made the circuit, but I forgot to connect the ground. Actually, uh, you will also know by yourself. You will know more about anything while you are doing on your own. And that's it for my part. And I forgot about this power pins. Whenever you are using sensors, some sensors will require very less power to turn on. In that case, you can use these pins, or in the circuit whenever you want to uh, make this some switches some kind, you can use these pins for powering some small circuits, and even you can use within this Arduino for some purposes. You will later come to know about those. And yes, and there will be some protocols. Here you can see them. There will be different devices work with different protocols. I mean, we know that we can connect displays, we can connect sensors, we can connect SD card readers, and so many devices can be connected to this Arduino. Some devices will work like this motor drives, and some small basic sensors will work with normal pre-programmed, I mean, uh, digital write or analog write. But there will be some devices which will be uh, using some different protocols to communicate with this board, which will be digital communication, but some protocol will be there. Whether, I mean, they will send data packets at different sizes or different rate, and those all things will be there. You can explore them on your own. There will be this I2C, which will be used for using displays, OLED displays, and everything. And this SPI protocol for using memory card reader in integration with Arduino. And this USART, this will be used for communicating between computer and Arduino. Whenever you write the program into this Arduino, this will use this USART protocol, which will be written onto this. You can see this chip now. This chip is converting that. This is an interface between computer and Arduino. Actually, it is connected to. I mean, the protocol used by this chip is UART. Like that, you will get to know more things when you start doing things. Yes, that's it for today. If you have any doubts or if you have anything, you can.
भैया
Yes.
पावर पिन में जो लिखा हुआ है 3 वोल्ट 5 वोल्ट ये मतलब क्या
Sorry, I didn't. Your voice is cracking.
बोल रहा आवाज आ
Hello.
रहा है आवाज नहीं आ रही
Yes, your voice is coming, but it is cracking. No.
अच्छा चैट में सॉरी
Uh, if you're having any problem, you can write it in chat box. Aryan. In power section. Yes, there will be an sensor board which will require only 3.3 volt. Actually, there will be an different boards actually. One board will work at 5 volt logic, and another board will work at 3.3 volt logic. And similarly, there will be sensors and modules which will be working at 5 volt and 3.3 volt. So, and it's an to say, it is an controller specific. We have seen this Arduino Uno. It will be working at 5 volt. If you see ESP32, which will be working at 3.3 volt. It depends. How the chip is designed. It will be. Even if the power they will. While they are designing, they will keep them either 3.3 volt based on power required to turn on thing, and based on proper. Yeah, is we need more than 5 volt for something that we have to do. Yes, there will be necessity. If you want to turn on an light with microcontroller, then you cannot do it directly with a microcontroller. We will be requiring an relay. I said in previous class, I said about isolator devices, which will be isolating two circuits, either optically, either it will be having an LED and photo transistor, or it can be having an uh, mechanical mechanical thing which is used in relay, and then we will use those components for turning the light on. If you want, I can show you some high power running motor with using relay. I'll show you in a minute. Yeah, which is
Bhaiya,
used.
what is the purpose of the PWM pins?
They will generate an pulse of 0 and 1. uh, in a way such that the resultant of the pin will be 3 volt, or what happens is, whenever you have a motor, the motor speed can be controlled by controlling the voltages at its terminals. uh, it will be having some threshold voltage. Below that it won't work. There will be an voltage where it works. From that voltage to some voltage, there will be specification. 0 to 9. somewhat like that. If we assume 0 to 9, we can control speed by controlling the voltage. Which pin is used to power? Actually, we can power Arduino Uno by three methods. Uh, you can see we can use this pin. You understood now regarding this 5 volt and hello, uh,
Yes,
Aryan.
भैया.
जी भैया.
Yes, and Yuvraj Chauhan. I mean, you also understood, no? Hello.
Yes, भैया.
जी.
Okay. Yes. Now Charan Kumar. Which pin to power? As Arduino can be powered using three ways. Uh, we can use this 12 volt input, which will be reduced to 5 volt for powering. I mean, it will be having some circuits here, which will be converted into 5 volt power, and we can use this USB port to power, and we can even use this bean pins to power. It will be based on your application, how you are going to work. I mean, maximum of the times we will be using our laptop USB port to turn on the USB. If you made some uh, device which will be kept at somewhere where uh, I mean, it is not possible to place a computer. You will be using this 12 volt adapter to power this Arduino. And even if you are using this microcontroller as a sub part of your system, you can use these pins. I mean, you will be having a series of microcontroller boards which are cascaded to those specific tasks. Then, whenever you are having some larger board which can provide a sufficient power to run this board, you can use those pins to power this thing. It will be depend on where you use and how you want to use. Is it clear? Okay, I think everyone uh, and you can explore more on your own. You will be finding some more tutorials in YouTube, or even you can hover through websites where you can find some interesting projects. I'll show you one. This thing. And you can check about uh, sonar sensor. I mean, you can check about different sensors, and you can check how they work, tutorials on them, so that you will get understanding. And in addition to that, you can learn programming. I mean, if you are already familiar with C or CPP, then it won't be a difficult task to program this microcontroller. Yes, that's it. Anyone having any queries? I think we can wrap up the session. Pratik?
Yeah, guys, if you have any queries, you can ask, or we'll wind up the session here.
भैया, during offline mode, how will we do the classes like in Sundays?
Sundays, see, the classes will only conduct like max to max, like 5 to 6 classes more will conduct, and I think up to 5 classes now. The college will be for you now. The mode will be in online only.
Yeah, we have shared you a schedule. I think we have 4 classes up to March. Yeah, next class is on March 27, and after that April 17th, I think. 1 second. Yeah, next class is on March 27, and after that, April 3rd. Only 4 classes. Uh, but the thing is, classes will go on in online mode only. When you come to college, then we will recruit and then we will take into the club.
Yeah, once the classes are over now, we will do one recruitment process for recruiting new members in our club. Then once the college is, I think from June now, everyone will be in offline mode. So then we can make some physical projects. We can do some projects in our robotics lab or robotics room. Then there is a robotics room in the college. We can do some interesting projects, or we can participate in competitions. Then we can do some more. Like for now, the classes will be like SOAR classes will be in online mode. Okay, you share, Harshita, you do one thing. You again share the WhatsApp group link here in the chat box. Okay, the WhatsApp group link has been shared. So, guys, if you have any more queries, you can ask, or we'll end the session here. Okay, so I think we don't have any more queries here. So, okay, people, you can leave now.